Hello, my dear geometry students. Here is the wrap up of the practice quiz for your upcoming quiz this week, March 19th and 20th. I'm going to just go over numbers 10 and 11. In number 10 here it says, is it possible to form a triangle with the side lengths 8 centimeters, 5 centimeters, 3 centimeters? If not, explain. This one is fairly simple. The theorem says the following. It says that the sum, let me get a pen that will write here. It says the sum of any two sides or side lengths of a triangle must be greater than the length of the third, meaning the third side. If you're willing, rehearse this with me. The sum of any two sides of a triangle must be greater than the length of the third. So we would take, possibly you could take the smallest two sides here, and you could simply say 5, meaning centimeters, plus 3 is equal to 8. And how does that compare with the third side? Third side is 8, so you'd say 8 is not greater than 8. So you'd say simply no, meaning it cannot form a triangle. Now that's the simplicity of that type. Let's just take another example to give you a little bit more practice or to give you another exposure. What if I gave you side lengths of, let's say, 9, 6, and 14, talking about inches, say. Well, you take the smaller of the two, usually is that where you start. You say 9 plus 6, and you add that up, that's 15. So 15 is greater than the third side, 14, so you say that checks out. You take another two, you'll take, say, 6 and 14. You say 6 plus 14, that would give you 20. And 20 is going to be greater than the third side. And the third side here is 9. So that checks out. And finally, you take the last two, 14 and 9. Say 14 plus 9. That's 23. And that's going to be greater than the third side, 6. They all check out. So you'd say yes to this. Yes. Meaning what? These side lengths can form a triangle. So that would be for the side lengths, let's say 9 inches, 6 inches, and 14 inches. Finally, number 11 says, if two sides of a triangle have lengths of 9 inches and 1 foot, find the possible lengths of the third side. Show your work. So you got 9 inches and 1 foot. Our units are mixed here. So what we want to do is we want to compare apples with apples. So we have to bring the feet, let's say, to inches. So we know that 12 inches make up 1 foot. So instead of looking at 9 inches and 1 foot, we can look at 9 inches and 12 inches. And then we say, oh, what will the side length of the third side be? And here's how I told you to get it, or here's how you could get it. The low end, or the minimum, you'd get that by subtracting these two from each other. You subtract the smaller from the larger here. So your low end you get by saying 12, take away 9, that will give you 3. And your high end, or your ceiling, you get by adding these two. So you 12 plus 9 will give you the maximum, or the ceiling that you can have, and that is going to be 21. So you report your answer as follows. You say x, or the third side length, can be greater than 3 and less than 21. Okay? You might say, well, how about 3? Could it be 3? Well, let's examine that. If one were 3 and the other two were 9 and 12, talking about inches, what would that mean? It would mean 3 plus 9 is 12. That's not greater than 12, so that wouldn't work. It would have to be greater than 3, like say 4. 4 plus 9 is 13. 13 is greater than 12. At the other end of the spectrum, where we have 21 being the ceiling, say, could it be 21? Well, let's examine. They give us 9, 12, and now 21. Look what happened. 21 is a third, let's say, and now 12 plus 9 is 21. Is that greater than 21? No. So it would have to be, let's say, 20. Where 12 plus 9, 21 is greater than 20. That's why the answer here is a good answer, saying that the third side length x would have to be greater than 3 and less than 21. Again, how do you get the low limit? You subtract the two from each other. How do you get the high limit? You add. And report it like this in inequality form. All right? God bless you, and I trust this will be very helpful to you.